Slope fields. What slope fields are? Sometimes they're called direction fields or directional fields. They're just a field or graph of slopes. That's all they are. So we just, on a graph, we just tell what the slopes are. What is the slope at each point? And we just draw little directional segments to tell that what that is. That's pretty much what it is. So when you look at a graph, you can tell what the derivative is at a certain point. Okay? So that's pretty much what a slope field is. It tells us what the slope is at a given point. Okay? So for example, first one, example A. So we're going to draw a slope field. Our equation is 2y. That's our derivative equation, right? And what derivatives do are they tell you slope, right? That's what derivatives' job is to do. They tell you slope at a certain point, okay? So what we're going to do is we're going to draw a slope field for 2y. That's our slope, okay? To do that, you choose a point. Well, we have 25 points there, okay? So we got to do one by one. All right. So let's start with the easiest one. Sometimes it's the easiest one. 0, 0. 0, 0. Okay, so at this point here, what is my y value and what is my x value? 0, 0, right? X is 0, y is 0. So to come up with the slope field, you're going to plug in those values in here. More specifically, in here. Okay? So dy over dx equals 2. So wait, let me write this again. So dy over dx, in other words, the derivative at 0, 0. So we plug in 0 for x and 0 for y. Well, we don't have an x, so I can't plug in 0 for x, but I can plug in 0 for y, right? So I plug in 0. 2 times 0? 0. So the derivative, or the slope, of the tangent line at 0, 0 is 0. How does a 0 slope line look like? If you saw a line that had a 0 slope, what would that line look like? Horizontal, right? It'd just be horizontal. And that's what we're going to do. We're going to draw a little segment, little horizontal segment right there. That shows that at 0, 0, the slope is 0. Pick another point. Let's move one to the right. So the point to the right is 1, 0, right? 1, 0. X is 1, y is 0. Well, again, I don't have an x, so I can't plug in 1. The only thing I can plug in is 0. And I get 0 again. So that means the slope at 1, 0 is 0. Now there's a lot of dots. There's 25 dots I got to cover. So the easiest way to do this is by looking for patterns. I saw that the first 2 that I have are 0. Is there anywhere else where I would have a 0 slope? So I have 5 dots, 5 dots. So what are you talking about? So be more specific.
So like on the y graph 1, 0, y graph 2, 0, negative 1, 0.
So on this graph you're talking about?
Yeah.
Okay. So name a point.
0, 1.
0, 1. Okay, let's check it out. 0, 1. 0, 1. Okay, for 0, 1. So now we're talking about this point right here. So we plug in 1 for y, and we get 2. That's not 0. It's okay, though. It's okay. So what would a 2 slope look like? If I had a slope of 2, what would it look like? So this is where we got to kind of estimate, right? A 1 slope means I go up 1 over 1, right? That'd be a 1 slope. A 2 slope has got to be a little more inclined. So something kind of like that. Okay, so anywhere else, before we start doing the rest of them, because I don't want to have to do 25, I don't want to have to do this 25 times. Is there anywhere else that's going to have a 0 slope? Mm-hmm. Wherever, it looks like wherever y is 0, that's where you're going to have a slope of 0. So let's see. Y is 0 here. Y is 0 here. Y is 0 here. Is there anywhere else this thing would have a 0 slope? Okay. So let's go. We're looking for patterns. So we don't have to do every single one of these. We can say, oh, everywhere this happens, this will happen. Everywhere this happens, this will happen. We're looking for patterns here. Okay, so let's go. Let's move to another. Let's look at this guy here. 1, 1. Okay, nowhere to plug in x, plug in y. Slope of 2, just like the last one, just like the one right next to it. Is there anywhere else it's going to have a slope of 2? Everywhere where y is 1. That's specific. I can tell everywhere y is 1, right? So when we're doing this, you got to be specific. Everywhere y is equal to positive 1. You just try to estimate. Okay. Let's go up 1. 0, 2. Zero, 2, I plug in 2 for y. And I get 4. So a 4 slope means you go up 4 over 1. That's pretty steep. Anywhere else, I would have a 4 slope, wherever y is 2. So these aren't exact, but you want to show that. You want to be able to see that these slopes are a little bit smaller than these slopes. These slopes are the biggest slopes, right? So I know it's hard to kind of picture what would it look like, but that's what you want to draw. Okay, it's why we call it. It's why it's an estimate. It helps us estimate. Okay. All right, so let's go below the x-axis. 0, negative 1. So negative 1 has a slope of negative 2. So it's going to be perpendicular to the, or not perpendicular, it's going to be going the other way. So these guys are positive 2 slope. Now we want a negative 2 slope. And it looks like everywhere y is negative 1 will have the same slope. Okay. All right. Last line. 0, -2. -4. It looks like everywhere y is -2, it's going to be -4. And you're done. That's a slope field. Now you can estimate what the slope would be at any of these at any of these points. To find the actual slope, you would have to use this, but you know that these guys are 0. These guys are positive, so they look like maybe. So if I didn't know, I would say these guys are probably +1, +2, around there, and I would say these are a little bit bigger. That's all you got to be able to tell. Okay. So on a test, if you had this guy go in the opposite direction, obviously that's going to be wrong, right? If you had that guy go in the opposite direction, but if you had this guy looking like that instead, I'm not going to mark it wrong because it's an estimate, right? Estimates mean close. Okay. Okay. And again, it's part A is going to help you with part B. Suppose that you know the point 0, -1. All right. So let's go find the point 0, -1. Right there. Suppose you know that the point 0, -1 is on the particular solution, okay, of the differential equation. So what we did last week. Right? Doing this process. This process is called finding the particular solution, right? That's what we did last week. Okay? By following the slopes, draw the diagram above what you think the particular solution would look like. So how do we draw? So we start at the point they give us. So we're going to start there. And we're going to go to the right, and we're going to go to the left. So I'm going to go this way, and I'm going to go that way. I'm going to go this way and that way. Now, which way do I go? Up, down, right, left? You follow the slopes. Now, at this point, what slope is it at this point? -2. So I'm not going to go up because -2 slope means I go down, right? So I'm going to go down here. And as I go down here, I have a bigger negative slope, right? So the way I'm going to go is I'm going to go with the flow. It tells me to go down. That's the way it's going to go. Now when I go left, again, I'm not going to go down here. I'm not going to go in this direction because the slope here means I'm going this way, right? So if I go this way, what happens as I get closer to the x-axis? Flattens out, right? It's going to flatten out. I'm not going to cross because the slopes here are 0. So I'm going to flatten out. You just follow the directions. Follow the directions. I'm not going to cross. I'm not going to cross a line. I'm not going to cross this way because the slopes here are 0. A slope of 0 means you flatten out. So if it flattens out at the x-axis, I can't cross it. Okay? The graph will follow the pattern of the slope field, but may go between points. Okay, so now what we're going to do for part C is we're going to do what we did last week for this guy. We're going to do what we did last week on practice 9, what we did, okay? And see what happens. Okay. What was the first step that we did last week? Move y's to the left and x's to the right. That's what we're going to do. Okay, so multiply both sides by dx. And then I got to divide by y. Okay. After I did that, that's when I did my antiderivative. What's the antiderivative of 1 over x or 1 over y? Natural log, right? Natural log. So it's going to be natural log of y equals 2x plus c, right? After I did that, what was my third step? Before that. That was the last, or solve for c, yeah. So how do we solve for c? Plug in 0, negative 1 for y and x, and solve for c. So y is 0. Oh, sorry, y is negative 1. X is 0. We talked about this last week, right? We can't have a log of a negative number. It doesn't work. There's no power that can make the number negative. So what do? Well, this is when we need the absolute value bars. So it's actually going to be positive 1. The only time we need the absolute value bars is when it's a negative log. When it's a positive log, you don't need them. So natural log of 1 is 0. 2 times 0 is 0. So c is 0. Last step, solve for y. Now, how do I solve for y if it's a natural log? What was the step that we did? The little loop trick, right? E is the base here. So we do our little loop trick. Start there, go there, go there. So e to the 2x power equals y. So what does this mean? Well, if you were to graph this e to the 2x, guess what the graph would look like? The blue thing. The blue thing. So what we're doing is exactly what we did last week. The only difference is we're using graphs to do it, right? Graphs to do it. So that's why I put these two sets of notes together, because essentially you're doing the same thing. One is graphically, one is through the 4 steps that I gave you, solving differential equations. It's essentially the same thing. Okay. Okay, so let's do another one. Okay. Less dots, 12 dots instead of 25. So there's half of them now, which is nice. But I have to draw the slope field for this guy. This guy's got an x now. Last one didn't have an x. This one has an x. Okay. So let's start with 0, 0. Every one of these dots has to have a slope on it, just like we did this guy. Okay. So 0, 0. X is 0, y is 0. So dy over dx for 0, 0 equals, I have x minus 1 over y squared. So at 0, 0, x is 0, y is 0. 0, 0. 0 minus 1 is negative 1. 0 squared is 0. What type of slope is negative 1 over 0? Undefined, right? Undefined, right? What does an undefined slope look like? 0 slope, vertical. Vertical. Just like that. So undefined is not a number, but it is a slope. We can draw the slope. Okay, so put your thinking caps on. Is there anywhere else that would have a 0 or an undefined slope? Anywhere y equals 0. Anywhere y equals 0. So this guy, this guy, this guy. Okay. Let's go one level up. Zero, 1. So this time x is 0. Or sorry, nope. Yes, x is 0, y is 1. So I get negative 1 over positive 1, which is negative 1. It's going to have a slope of down 1 over 1. Okay. Let's go here, 1, 1. 1, 1, I get 0 over 1. 0 over 1 is 0. We know a 0 slope looks like that. Vertical or horizontal. Is there anywhere else that would have a 0 slope? When am I going to always have a 0 slope for this guy? When x equals 1. When x equals 1, that'll give me 0 on top. 0 on top means 0. That guy too. Okay, we got 4 more. Now this part, like if you can do some of these in your head, do them. Like if you can do some of this math, because some of this math isn't bad because you're just plugging in here. So mental math, that's perfectly okay. To build slope fields, mental math is perfectly okay. To do step B, it's not. But to do step A, sketch the slope, do it in your head. Look for patterns. Look for things that you don't have to do again and again and again and again. Okay? So how about 2, 1? So over here, 2 comma 1. So x is 2, y is 1. So that's going to be 1 over 1, positive 1. And then 2, 2. 2 and 2. So we get 1 over 4. 1/4. A slope of 1/4 means I only go up 1 over 4. So it's a little flatter. Not quite 0, but flat. Okay, 2 more. Negative 1, 1. Negative 1, 1. So negative 1 is x. Positive 1 down here. So I get negative 2 over 1, which is negative 2. It's a little bit steeper than negative 1. Oh, I skipped 0, 2. 0, 2. X is 0, y is 2. Negative 1/4. One more. Let's see, negative 1, 2. Negative 2/4, which is negative 1/2. So it means down 1 over 2. Down 1 over 2. Done. So like I said, when you're creating a slope field, mental math is perfectly okay. Mental math is perfectly okay. I don't mind that. Okay, so B now. So now they want us to find the particular solution of the guy we just did at 0, negative 1. So B is just what we did last week. Okay. So we start with this guy. Everything y related goes to the left. Everything x related goes to the right. So y squared dy equals x minus 1 dx. This part I'm going to go a little fast on because we spent pretty much all week last week doing this, so it's the same. So let's see, there'll be 1/3 y cubed equals x squared, 1/2 x squared minus x plus c. Plug in your point. Plug in 0 for x, negative 1 for y. So I get negative 1/3 equals c. This guy cancels out, that guy cancels out. So I get 1/3 y cubed equals 1/2 x squared minus x minus 1/3. Last step, get y by itself. Okay, so I'm going to multiply both sides by 3, or 3 over 1. So I get 3 over 2x squared minus 3x minus 1. Cube root. Opposite of cubed is cube root. So I get y equals the cube root of 3/2 x squared minus 3x minus 1. This one is not, great question. Will this be plus or minus? It's not, because it's cube root, and I can have negative cube roots, right? Because it's three numbers, right? So I can have a negative times a negative times. So yeah, great point. Yeah, it would be plus or minus if it was square root, fourth root, 6th root, 8th root, even number root. Yeah, great point. Okay. This type of question right here. Big time FRQ question. So when you take your FRQ and whenever we take the next test, this is only the first lesson, so it's going to be a while. But when we do take it, guarantee you're going to see two things. You're going to see a graph like you did last lesson, right? Graph, and you got to analyze the graph, right? Find where it's increasing, decreasing, find out where it's relative max, relative min, points of inflection, all that stuff, right? That's going to be one FRQ. This will be the other FRQ. They're going to ask you a question just like this. They're going to say, draw a slope field. And then they're going to say, find the particular solution. Those are just big FRQ questions for this chapter. Slope fields aren't big multiple choice questions. You don't see slope fields for multiple choice questions a lot. Sometimes you do, but they're not really that. They're more FRQ type stuff. Okay? So the last thing is just kind of matching. Doing some matching. The last page is just some practice doing matching. You have two graphs. Slope field's already done for you. The slope field is already done for you. You have 8 general solutions. Means these are the originals. These are the derivatives. The derivatives of these guys were used to come up with the slope field. Okay, it's different than the ones we've done. So if you were to find the derivative of A, B, C, D, all the way to H, that's what you would use to come up with these slope fields. So now what I want you to do is match. So there's only 2 graphs. There's only 2 graphs. Which one matches number 1 and number 2? A, B, C, D, F, G, or H? If you were to see this on multiple choice, this would be the type of thing matching, where they give you 4 graphs and they give you 1 differential match, or the opposite like this. Okay, so try it now or try it on test day. And you don't want to try it on test day. You want to know it on test day. So try now. If you make a mistake today, right? You don't want the first time. They don't give you derivatives. If you want to look at derivatives, you have to find derivatives. So that's why I drew the bottom, A through H. The original A through H, there are no derivatives. These are all original equations. So the derivative of A, what's the derivative of 1? So all of those slopes should look like what? Yeah, and those guys aren't all horizontal. Some are going up, some are going down, some are going up, So A is not going to work for either. B, what's the slope of just X? Or what's the derivative of just X? Okay, a slope of 1 goes up 1 over 1. That means every single dot has to look like this. That's not the case. So this one isn't going to work. What's the slope of X squared? 2X, right? The derivative of 1/3 X cubed is X squared. The slope of, F is cosine, negative sine, and then the slope, I believe it's -1 over X cubed or something like that. So I'm looking for which of these guys looks like that. Well, follow the waves. This one looks like it's going down, then going back up, then going down like that. That's either the sine wave or the cosine wave, right? Well, I have two options. I have negative sine or cosine. So sine looks like that, right? Starts going up. Cosine starts going down, right? This guy starts going up and then goes down, right? That's not going to be, that's not cosine, because so cosine starts going down and then goes up. So that one looks like G. Let's see. This guy over here looks like it goes like this. That's a cubic graph. I only got one cubic, right? So that one's going to be D. Okay. Now the one right below it is different. So these graphs should match these guys. How do I find each slope? I use this guy. It's a little confusing. When you look at the actual graph, whatever the slopes are doing should match the original. Okay? The derivatives we use to find each of those little tick marks, each of the little segments. Okay? So the graphs aren't going to match these guys. The graphs are going to match the original. Here's the thing. They usually won't give you the original. They'll give you what they did down here. They'll give you a bunch of derivatives. So it's not that easy. So like here, sine. Oh, which one looks like sine? No, because that's not the original. Okay? These are the derivatives. So what I want you to do now is use the derivatives to match. Okay? Each one is only matched once. Each one is only matched once. So 1 through 6 matches with A through F just once. Last thing. Okay, so letter A, like I said, looks like you get a 0 slope everywhere y is 0. So that means if I plug in 2 for y, I should get 0. So which one, 1, 2, 3, 4, 5, or 6, when I plug in 2 for y, will I get 0? Which Roman numeral? 3, yeah. Roman numeral 3. If I plug in 2 for y, I'm going to get 0. It doesn't matter what x is. So 3 and A go together. Okay. B. Every time x is 0, I get 0. Which one, if I plug in 0 for x, will I get 0 as an answer? 4. Is there anywhere else? There's 2 more. Number 2, right? Number 2, if I plug in 0 for x, I would get 0. And number 6, if I plug in 0 for x, I would get 0. So that doesn't really help us there. Okay? Let's go on. Let's see. So B and D. So let's look at E. Let's look at E real quick. E looks like there's kind of steps. It looks like at 0, 0, 1, 1, 2, 2, 3, 3, when x and y are exactly the same, they make 0. So which one, if x and y are exactly the same, would make 0? Number 5. So 5 and E looks like those go together. That's the only ones. Okay. Look at D. Follow the waves. Doesn't that look familiar? D, if I were to follow the waves, I go up, down, up, down. That looks like a cosine or a sine graph, right? The derivative if the derivative is sine, that means it came from cosine. So this guy could be a cosine graph, right? Or a negative cosine. Right? Number 4, everywhere x, whatever I plug in for x is always going to be the slope, right? Whatever I plug in for x will always be the slope. So if x is 0, it's 0. If x is 1, it's 1, 2, 3. So x is getting bigger and bigger. Same thing over here, right? It's getting smaller and smaller. So 4 in B. So I have C and F. Let's see. So F. If I were to follow the curve for F, it looks like it slows and then it picks up. That's an exponential. That is number 1. And so the last one has to be number 2. Okay? We'll do some more practice with this tomorrow.